Good morning. This is your Stat Sensei, Mr. Spensei, and this is an exit ticket on errors. So, due to road damage that heavy trucks cause, the Department of Transportation limits the mean weight of a particular truck to 19,000 pounds. If the mean weight of a trucking company, if the average weight of a trucking company exceeds 19,000 pounds, additional fees and fines will be incurred. In other words, they're saying an individual truck might be overweight, but you're on average, you can't be. The state police decided to check a random sample of 40. All right, so we have a sample size of 40, randomly collected, um, of a very large state trucking company that has more than 4,700 trucks. So 40 is definitely less than 10%. The mean weight and standard deviation of the sample are 19,168. So there's our X bar. So let's write some information down. The population mean, that's the claim, 19,000. The problem, or X bar, in this case is 19,168. We have a sample size of 40, and we have a standard deviation of 2,324. The mean weight and standard deviation of the sample are this. Use an appropriate hypothesis test and test at a 5% level of significance. So there's our alpha, 0.05, to determine whether or not the company should be fined. Well, they only get fined if it's greater than. So that means our null hypothesis will be HO, mu equals 19,000. HA, mu is greater than 19,000. And my formula is, and I guess I should put a label on these, pounds. My formula is T equals X bar minus mu S divided by square root of N. So when I plug in, I have T equals 19,168. That's my sample mean, minus the population mean of 19,000 divided by the standard deviation of the population, of the sample, standard deviation of the sample. If it was a standard deviation, because it's a standard deviation of the sample, it's a T. If it had been a standard deviation of the population, it would have been a Z. All right. So let's go ahead and plug this into the calculator real quick and see what happens. So stat test, T test, there's my mean of 19,000, my sample mean of 19,168, my sample standard deviation of 4,700, and my sample size of 40. If we exceed, so that means we have greater than, and that's what we have there, so make sure that's highlighted. We end up getting a T statistic of 0.2260. So the probability that T, look at this, is greater, so T is greater than 0.2266 equals a p-value of 0.411. That's a pretty big p-value. 4111. Make these the same length. 4,111 is definitely bigger than 500. So our decision is fail to reject. All right. So we failed to reject. And by the way, if we were to check our conditions, which we need to, we would sit there and go, hey, random sample, that was met. N is less than 10% because 40 times 10 is 400. That's less than that 4,700. And our sample size was 40, which is greater than 30. So the distribution of the sample means is approximately normal by central limit theorem. So all the conditions were met. We needed to define the parameter, but that wasn't the purpose of this. The purpose of this was to determine what type of error might have been committed. Now, we ran the test properly. Everything was done correctly. Random sample, everything was done. So no errors could have been committed because the test was run properly. That has nothing to do with it. You always run the test properly, or hopefully you do, but this happens by random chance alone. Errors happen by random chance alone and are actually due to sampling error. All right. Remember at the beginning of the year, we said, hey, just because you put everyone's name in a hat and drew and you had freshmen, sophomores, and juniors and seniors, you may have overrepresented the freshmen, even though you mixed and drew, or maybe you underrepresented the sophomores or some other group. That's random chance. That's not any error, not any error was conducted in the way the test was conducted. We just had sampling error or sampling variability. So really, when we're talking about errors, we're talking about sampling variability or sampling error. Also, we don't know that a mistake was committed. Everything looks like it was done correctly. If we knew an error was committed, then we'd go back and fix it. We'd have to have a lot more information to know that it was committed. Just running the test, we have no way of knowing. So we don't, it can't be these two because we don't have enough information to make that decision that it was. So the question is, what type may have been committed? Well, if you reject, you may have committed a type 1. Now, if you fail to reject, and I'm going to put over here, I'm going to put the number 2. Fail to reject, oh, type 2. Fail to, type 2. Fail to, type 2. So if you fail to reject, the only type of error that you might have committed is a type 2. So our answer choice is D there. So refer to scenario 2 and explain the consequences of committing a type 2 that you selected in the context of this scenario. All right, so I'm going to go ahead and write my null and alternative again. My null was the trucks are the mean truck price or truck weight is 19,000 pounds. The alternative is the mean truck weight is greater than 19,000 pounds. All right, so if I commit a type 2, I fail to reject this, which means I believe the null in error. And HA is true. Another way to say it is, I believe the hoe and it was a lie. So you believe the lying hoe. Okay? Bad idea. So in this case, a type 2 error would be believing that the average truck weight is 19,000 pounds when in fact it is greater than 19,000 pounds. The consequence is that the roads get damaged by the extra weight of the trucks. All right, one thing I should have said up there at the beginning. So in this case, well, first off, in this case, a type 2 error would be believing that the average truck weight is 19,000 pounds when in fact it is greater than 19,000 pounds. The consequence is that the road gets damaged by the extra weight of the truck. You have to have this whole thing. I would highly recommend that you add this part above it. A type 2 error is failing to reject type 2 error is failing to reject a false null. All right. Oop, that needs an L. A type 2 error is failing to reject a false null. All right. Beta measures the probability of a type 2 error. So beta would be the probability of committing a type 2 error or probability of failing to reject a false null. All right. Sure hope that helps. Appreciate you watching and hope to see you on the next one. Thank you.